name is Vasav Sahni and I'm a scientist at 3M. Welcome to Science at Home. One of my passions is to advocate science and careers in scientific research. Through 3M's Young Scientist Lab, I've been able to pursue my passions for the last few years. One of the myths that I want to dispel about science is that to do good science, you need a big lab and expensive equipment and expensive materials. That is largely incorrect. Good science starts with observation and curiosity. Growing up, I was always intrigued with things in nature, particularly how things move in nature. And when we think about movement, we think about liquids. And the most common liquid on planet Earth is water. Water is extremely interesting. There are things that sink in water. There are things that swim in water. There are things that float on water. But did you know that there are some insects that also walk on water? Growing up, I was always fascinated by how these insects walk on water. Another phenomenon regarding water is dewdrops. Have you ever seen dewdrops on grass and wondered why they don't slide down? To understand these phenomena, we must first understand surface tension. Surface tension is the cohesive strength of the surface of liquids. The surface of liquids acts like a skin. The stronger the skin, the higher the surface tension. There are liquids like water and liquid mercury that have higher surface tension than other liquids like oil, soaps, and detergents. I know the next question in your mind. What happens when you mix liquids with two very different surface tensions? To find out the answer to this tense question, let's do this experiment. For doing this experiment, we need the following things. First, we need a pan or a bowl in which we'll be filling some water from the tap. I've already done that. We need a pair of scissors. We need something to apply a soap or any low surface tension liquid. I have cotton swabs here. You can also use toothpick or also your finger. I have some soap. Dish soap is best, or you can use any other kind of soap. And then you need something with which you're going to make a boat. I have a piece of plastic here in which I have made a notch in the back and the front of it is pointed. You can also use a bread clip and you can make the front pointed, or any material that does not absorb water, and that will allow you to cut it to form the notch and the front, which is pointy. Anything that doesn't absorb in water will help this boat to float on water. Before we do this experiment, we must first address safety. You must have seen scientists wearing gloves and glasses when they're working with harsh chemicals and high temperatures. The materials that we are using here are generally safe, but we are using soap, which could be an irritant if you get it into your eye, so I'm still wearing my glasses. To start this experiment, we will carefully place the boat close to the edge of the pan or the bowl that you're using, and then use this swab to introduce the soap at the notch of this boat, like so. Before I do that, I want to ask you, what do you think will happen when I introduce the soap in the notch of the boat? Make your predictions before I do this. When I introduce the soap here, you will see that the boat zooms forward. Anytime you do that, when you redirect the boat goes away from where the soap is. Now, why do you think that happens? It happens because of the difference in surface tension of the soap and also of the water. When there are two different surface tensions, the liquid prefers to move from a region of low surface tension to high surface tension. This is called the Marangoni Effect. When we introduce the soap molecules will go away from the boat towards the water and thus propelling the boat in the opposite direction. The same principle is also used in rockets when the fuel emits from the tank, thus propelling the rocket upwards. Now, to understand this phenomena more, I would encourage you to play with some of the variables in this experiment. The first variable that you can play with is the material, the size, and the shape of the boat, and also of the notch in the back. Other materials that you can play with are the soap. I've used dish soap here, but I encourage you to use different kinds of soap so that you can figure out how the difference in surface tension of the soap and the water affects this experiment. I encourage you to write down your observations with the variables that you have changed so you can understand this phenomena a little bit more. I hope you have learned from this experiment and enjoy it. I encourage you to watch other episodes of Science at Home. My name is Vasav Sahni. Thanks for watching.